All right, let's dive right in. Today, we're talking about a fundamental, massive shift happening in the cloud data and AI landscape. It's a new reality where the old rules of competition, well, they're basically dead. In their place is a new ecosystem built not on rivalry, but on partnership. We're calling it the cloud partnership economy.
So, let me just start by asking you a question, one that every single software company has had to face. Can you, realistically, go head-to-head with the company that spends billions upon billions of dollars on infrastructure? I'm talking about the hyperscalers, Amazon, Microsoft, and Google. Can you really compete with that?
For just about every software giant out there today, the answer is a flat-out, resounding no. The era of trying to beat the hyperscalers at their own game, it's over. It's done. Instead, we've jumped headfirst into an age of co-innovation, where deep, strategic partnerships have completely replaced direct competition.
So how in the world did we get here? And more importantly, where is all this headed? That's what we're going to break down. We'll unpack this new cloud alliance, take a look at the technical blueprint that makes it all work, and see how both the old guard and the new cloud-native disruptors are adapting. We're also going to talk about how AI is basically pouring gasoline on this fire, and finally, what it really takes to survive in this brand new world.
Okay, first up, the new Cloud Alliance. Let's dig into the powerful market forces that have made these partnerships not just a good idea, but an absolute necessity for survival. Now, just take a look at these numbers. What's so wild here is the sheer dominance on display. Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Together, they control over 65% of all global cloud spending. You know, this isn't just a market lead, it's a gravitational force that literally shapes the entire industry. You simply can't ignore it. So you might be wondering, why would a software vendor, an ISV, choose to partner up instead of just building their own thing? Well, the reasons are just overwhelming. Partnering with a hyperscaler gives you instant global scale, practically infinite storage and compute power, and a battle-tested security and compliance framework for things like HIPAA and GDPR right out of the box. Trying to replicate that on your own is financially and logistically pretty much impossible. Instead, you partner up and get a golden ticket to a booming enterprise data market worth a cool $350 billion this year.
And this right here shows why it's such a symbiotic relationship. It's a perfect division of labor. The hyperscalers focus on what they do best, the heavy lifting of providing scalable commodity infrastructure and platforms. And that frees up the ISVs to focus on their specialized, high-margin, secret sauce, the sophisticated analytics, the AI models, the integrations that solve real business problems. It's a total win-win. The hyperscalers get high-value workloads on their platforms, and the ISVs get to innovate like crazy without the headache of managing global infrastructure.
Now, this whole partnership economy, it's not just a business model or a handshake deal. It's built on a very specific technical foundation. So let's take a look at the new architectural rules that make this whole thing possible.
The first pillar of this new blueprint, and it's really become the consensus standard, is the data lakehouse. Just think of it as the best of both worlds. You get the reliability and governance of a traditional data warehouse, but you combine it with the massive scale and flexibility of a data lake. It is the foundation for modern analytics and AI, period.
The second principle is a total game changer: zero-copy data sharing. For decades, getting data from one system to another meant this slow, painful process called ETL: extract, transform, and load. It created multiple copies of data that were often stale, expensive to store, and just a governance nightmare. Zero-copy sharing completely changes that. It allows different platforms and clouds to access the same live data without ever moving or duplicating it. It's huge.
And the third mandatory shift is FinOps. With all the complexity of multi-cloud environments, you just can't treat cost management as an afterthought anymore. FinOps makes financial accountability an engineering discipline. It means that architects and developers have to think about the cost implications of their designs from day one, proactively managing cloud spend instead of just reacting to a shocking bill at the end of the month.
Okay, so now that we have the blueprint, let's see it in action. Let's take a look at how the established titans of the software world are navigating this new reality. I mean, these are companies that were born in an on-premises world and have had to fundamentally reinvent themselves.
First up is SAP. Their whole strategy is about deep integration. Specifically, they're trying to unlock their vast stores of mission-critical ERP data for AI and modern analytics. They realized that all this immense value in their systems was basically trapped, and partnerships were the only key to setting it free.
So the crucial point is how they're doing this. Through a super tight alliance with Google Cloud, they're embedding Gemini AI models directly into their Joule Intelligent Agent. Architecturally, though, the SAP Business Data Cloud Connect for BigQuery is the real hero here. It enables that zero-copy sharing we just talked about, letting enterprises run analytics and build AI directly on live, trusted business data without the delay and risk of making copies.
Next up is Oracle, and they've adopted this fascinating strategy of ubiquity. Instead of trying to force customers onto their own cloud, they're making their legendary database services accessible across every major cloud environment. They're effectively decoupling their software from their hardware.
And wow, do the results speak for themselves. Oracle's cloud infrastructure is now running in 38 regions, hosted by its competitors, AWS, Azure, and GCP. They've introduced a multi-cloud universal credits model to make buying and using their services totally seamless, no matter where they run. This strategy has led to an absolutely staggering 1,529% growth in multi-cloud revenue. It proves that for a lot of customers, flexibility is now way more important than where the infrastructure is located.
And finally, in our look at the legacy guard, we've got SAS, a longtime leader in statistical analysis. Their challenge was how to take their powerful but traditionally monolithic platform and completely reinvent it for a world driven by cloud-native and open-source tools.
Well, through a tight partnership with Microsoft, their flagship SaaS VIA platform is now fully integrated with Azure. It runs workloads natively and connects seamlessly with key Azure services. But maybe the most important move they made was to embrace the open-source community, adding robust support for Python. This shows they get it. They have to meet data scientists where they are, letting them use the tools they love while still tapping into the power of SaaS analytics.
Okay, let's switch gears and talk about the cloud-native vanguard. These are the companies that were born in the cloud and built from day one to thrive in this multi-cloud reality. They aren't just adapting to the new rules, they're the ones defining them. Databricks is a prime example. Their data intelligence platform runs natively on all three major hyperscalers, so you get a consistent experience everywhere. Their strategy is all about leading the charge in unifying data and AI across this multi-cloud world.
What's really fascinating here is their dual focus on advanced AI and open standards. They've partnered with Google to make Gemini models a native part of their platform, which lets you build powerful AI agents on your own private data securely without ever moving it. At the same time, they're the key champions of Delta sharing, an open protocol for data exchange that has seen an incredible 300% year-over-year growth. This commitment to open standards is a strategic move to prevent vendor lock-in.
Next is Snowflake, another pillar of the cloud-native world. Their whole strategy is built around this idea of the data cloud, a seamless global ecosystem for data that basically hides the underlying cloud provider. It's all about cross-cloud mobility and collaboration.
Architecturally, Snowflake is fantastic at enabling business continuity with rock-solid features for replicating data across different clouds for disaster recovery. But their most ambitious move is pushing way beyond their analytics roots. With things like Unistore, they are now handling transactional workloads, the day-to-day operational stuff from sales or inventory systems. This is a huge deal. It blurs the traditional lines between analytical and operational data, as they aim for a single, unified platform for everything.
So let's just pull all of this together for a second. As you can clearly see, everyone's playing a different game. SAP and SAS chose deep integrations to modernize. Oracle is playing the ubiquity card, trying to be everywhere. And the cloud natives, Databricks and Snowflake, are in a fierce race to build the most comprehensive multi-cloud platform. The key takeaway, though? While all the paths are different, every single one of them starts from the same place, a deep partnership with a hyperscaler.
We've seen how these companies are adapting. But let's talk about the single biggest force that's accelerating all of these changes: artificial intelligence. I mean, generative AI isn't just another workload, it's a catalyst that is creating extreme new demands on infrastructure, and that's forcing even deeper levels of integration.
Just consider this number, 300%. That's how much more power NVIDIA's latest AI chips consume compared to their predecessors. This is not some small incremental increase. It's a massive step change that's creating a literal thermal crisis inside data centers. The sheer power required to train and run modern AI is forcing a complete rethink of the physical infrastructure that underpins the entire cloud.
All that power consumption is making traditional air cooling obsolete for high-end AI. You just can't pack enough GPUs into an air-cooled rack without it melting.
The only solution is a massive shift to liquid cooling, which can handle racks pulling over 150 kilowatts of power. But this introduces huge new engineering challenges, like reinforcing floors to handle cooling baths that can weigh over 4 metric tons. And this brings us right back to our central theme. Only the hyperscalers have the capital and the engineering expertise to build these specialized facilities at scale. This just cements their foundational role in the AI era even further.
And that brings us to our final section. How do you actually survive and thrive in this new, complex, and interdependent ecosystem? Well, success now depends on mastering both operational and financial discipline.
One of the biggest and, frankly, most insidious threats in a multi-cloud world is something people call the egress tax. These are the fees charged by cloud providers every single time you move data out of their network. They are often overlooked during design, but can accumulate into massive, unexpected costs that can absolutely cripple a project.
And as you can see here, the policies vary wildly. While AWS offers a relatively generous 100 gigabytes of free egress per month, Azure and GCP offer only 5. These fees are a powerful financial incentive to not move your data. And that makes architectures that avoid data movement, like zero-copy sharing, not just elegant, but economically essential.
So, based on everything we've seen, here is a 4-step playbook for success. First, mandate a zero-copy data architecture, just like SAP is doing. Treat data replication as an architectural failure. Second, invest in MLOps or machine learning operations, specifically in platforms that embed AI natively so you can manage the entire lifecycle of your models on live, governed data. Third, institutionalize FinOps. Make cost a day zero design constraint for every single engineer. And fourth, embrace architectural convergence, following Snowflake's lead to build platforms that can handle both analytical and transactional workloads seamlessly.
And that leaves us with one final provocative thought. In this new cloud partnership economy, your technical choices are no longer just technical choices. Your data architecture has become your financial strategy. So the real question is, are you ready for that reality?